Guys, we're talking about the law of sines today. You have seen this before, but obviously we're going to spend some more time going more in depth with it and using some of our new MAH knowledge. So let's talk about the law of sines. We want to be able to use it and understand when it can be used. So far we have used the law of sines to solve right triangles, right, as such. But now we're going to take some time and look at what's called oblique triangles. What are oblique triangles? An oblique triangle is not a right triangle. So we want to use the law of sines for any oblique triangle. And just keep in mind, which we already know, law of sines does work for right triangles too. But we're going to focus on some oblique cases. Okay, so here is the law of sine. Okay, so we have A over sine of A equals B over sine of B, which equals C over sine of B, which is also true for their reciprocals. Just want to remind you guys, these are the exact same thing. They're the same law. These are both the law of sines. Okay, when might you use one over the other? Well, for this one here, you know, if I were solving for, let's say, a side length, A, B, or C, it might be useful to use this type of law of sines. If I were solving for angle A, angle B, or angle C, if I was solving for an angle, I'd probably want to use this. Okay? You know, we want to use whichever one's better just to save an algebraic step. Even if I don't use the right one, which again, they're the same thing, we would just have an extra step. Okay? Also, just as a reminder to you guys, we do use capital letters for angles and then lowercase letters for sides, which is just me being picky about notation. Okay? So it says here, there are 3 scenarios of given information that will allow us to use the law of sines to solve for a triangle. To solve a triangle, not for a triangle. So what does it mean to solve a triangle again? It means to find all the missing side and angle measures. Okay, so anytime you're asked to solve, like the problem says solve the triangle, that just means find any of the remaining sides or angles. One of the scenarios that we would use law of sines is SSA, which is an ambiguous case. Backwards it spells a naughty word, never say it. And we also want to know that there are 2 other cases where we might use it. You know, based on looking at the law itself, we can kind of figure out when the other 2 cases are that we would use law of sines. So here's my question for you. Which of the following are the other 2 scenarios where we would be able to use the law of sines? I will ask you about this in class, so let's have you think about this. Circle your 2 answers, and we'll see tomorrow if you are correct. So go ahead, circle what you think the other 2 scenarios are. Okay, so here's the problem. It says find all the missing sides and angles of the triangle. In other words, I could have written this as solve the triangle. So let's have you guys do this. Obviously, since this video is called Law of Sines, you probably want to use the Law of Sines. Part of it you don't even need it for, but we'll see what you can do. Okay? So go ahead, put me on pause, and then we'll check your answers. Let's check our answers here. There were 3 pieces of information to the triangle that were left unknown. That was angle A, side length B, and side length A. So first and foremost, the easiest probably is figuring out angle A. We could figure that it's 35 degrees. Hopefully you got that right. For side length B, I'm using the law of sines here. So remember, since we were solving for a side length, it probably makes sense to use this version of the law of sines. So I got that B is 13.309. To find A, I just want to point out here, I could have used this new side length and then done 13.309 over the sine of whatever angle B is, which is 40 degrees. I could have done that, but just know that this is a rounded answer. So it's just nicer to use exact values, right? Use the given information instead of any rounded values. So that way we get answers that are closer to the exact answer. So that side length A is 11.876. Okay, so in conclusion, here is the law of sines. They're the same thing. One's useful for finding a side length. One's useful for solving for an angle. All right, good job.